özlərimizdə təqdim edeyim. Adım Kamala, soyadım Oghuz. Mən Bakı ALNF məktəbinin proseslərin avtomatlaşdırılması mühəndisliyi departamentində associate professor olaraq çalışıram və bu konfransa da modeling of the system for diagnosing asymmetry of the electromyographic signals using the correlation analysis method in the LabVIEW environment topiki ilə qoşulmuşam. Yəni icazə versəz başlayaram. First of all, let me to explain why the topic name is so long, and because this is I try to include all approach of what I work with them. This is object. Object is electromyographic signal, and then the method, which method I use. This is correlation analysis method, and the environment where I realize this calculations. This is a LabVIEW environment. Before all, I want to give very brief information about the object. This is this research. This research object is electromyographic signals from human body, muscles, which is currently generated from neuromuscular activity. You know, the object of research is very important because all our activity, daily activity, depends on, I would say, from our muscles, and asymmetry is one of main not diseases but problems related with our muscles. Yes, of course, we think that our body is symmetrical, but in reality, our body is non-symmetrical. But if this asymmetry is more than normal value, it could be very problems. It can be caused to very big problems. That's why the object is a very important research object. And the acquisition of this type of signals, biomedical and special electromyographic signals, realized applying these myographs, different type of myographs used in clinics and hospitals, 2 channels, 6, 8, and 12. I used 12-channel electromyograph, and in this figure you see result from electromyographic device. There are, as this device used 12 channels, there are we can see 12 signals, 12 outputs, but you know, in first glance it's a bit difficult to analyze in which muscle have the asymmetry, and that's why I try to use a very simple but more useful approach for calculating this coefficient, this asymmetry. And for work project is used 6 muscles, which are in this graph, and the symbols related with muscles, 12, of course. Why 12 signal? Because for grading asymmetry, we need pair muscles from left and right side. As a method, I use cross correlation, and this is a widely used approach method because cross correlation shows a relation to signals. If these signals are pairs from the same muscles, we think that this approach will show us a very correct result from these signals. And this is a function for calculating cross correlation correlation coefficient. And before I realized I calculate all result in a computer Yes, of course, in Excel program. This is diagram from Excel. This is if compare our result. This is from myograph, from device, and this is from calculating. Here we see cross correlation coefficient relation, such as separately measured result. This is very simple to analyze and see the relation, which muscles, which pair of muscles is injured and prone to asymmetry. And this result shows that this is a better approach to measure separately or to compare separately results as to get as say to compare coefficient of correlation coefficient for pair muscles. And from this result, we see that vastus or lateralis, this is a quadratic, this is a quadriceps femoris muscles, vastus lateralis, is a much more asymmetry pair from research muscles. And for realizing, for how to say, for showing interface, calculating this approach, I use LabVIEW. LabVIEW, this is graphical program for tests and widely used not only for medical and industrial different fields. There I have a lot of available functions, drivers, very easy to realize. This program have two parts, block diagram and the front panel. In front panel, we can design our system, and in block diagram, we can very easily connect realize all connections, all calculations. As the report from device given with Excel sheet, the first step I use how to transfer this data to LabVIEW. This is connected this output with my system, and there I have open Excel, close Excel elements, starts and end lines from sheet and control table where all information will write. And next is block diagram of the asymmetry determination subsystem with correlation coefficients. From this table, I separate each muscle result, and then I connect them purely from left and right side, calculate the correlation coefficient. This system have already this block for calculation correlation coefficient, and then I send this information and for getting this histogram. And in this graph, you see this histogram or in LabVIEW. And this is front panel of modeled system. Here we can see patient data, doctor data, and survey method. You see here by calculating the correlation coefficient based on asymmetric coefficient. There I have different methods for calculation asymmetry based on measured length of muscle, so on. And another side is a survey result. Here we can see not only just survey result and the muscles which are prone to asymmetry. I think it is a very big advantage of this approach is not only just analyze or see which muscle have asymmetry, but to realize which of them is prone to predict future future position or a statement of the muscles. And the last is a report, and this report in Excel sheet, we can send this report to the Excel sheet, and here we will see all information about from survey, name of patient, doctor information, and of course a diagnostic result. This approach, in this method, I use correlation coefficient, as I explained before, that these coefficients very easily, describes, very easily calculates and shows which muscle have this problem. And second, using this approach, we can very easily see not only just injured muscle, but predict which of them, prone to the asymmetry. And from another side, this is this result will help doctors or researchers increase accuracy, decision-making, diagnosis of asymmetry. Thank you very much for your attention.